Hello and welcome everybody. Um, Good evening, good morning, depending on where you are. It's great to see everybody. Um, hey, can you share the first slide again? Um, uh, yes, thanks. Today we're going to talk about security and compliance in Gen3 Data Commons. I think it'll be an interesting presentation. We'll have speakers from the Center for Translational Data Science at the University of Chicago, from the Open Commons Consortium, and from Crumware. And then the other sponsors are from the Australian Biocommons and the New Zealand eScience Infrastructure. Next slide. So just a little bit of housekeeping before we get started. You will all be muted by default, but please feel free to ask questions in the chat box during the presentations. If somebody gets done with their section quickly, maybe we'll have time for one or two questions, but in general, we're going to hold them for the end. Perhaps we'll respond in chat, but otherwise we should have plenty of time at the end to address anybody's questions. So yeah, I guess at the end, raise your hand and you can unmute if you like, or just type into the chat box. But today, I'm excited about the topic. We have 4 different presentations. The first presentation is going to be on 10 lessons learned about security and compliance by Bob Grossman, followed by security and compliance practices at the Center for Translational Data Science by Clint Malson. Then security practices for Gen3 and applications by Plamen Martinov. Finally, from Colin Griffin, securing cloud native and Kubernetes. So with that, I'm going to turn it over to Bob.
Okay. Give me 1 second to bring up my slides. What? All right, can everyone see my slides?
Yes, sir.
Okay, thank you. So this is an introduction. I'm taking the point of view that you're a project owner. You're not an expert in security and compliance. You want to bring up a Gen3 Data Commons, and you want to know sort of what are the core things you should think about, and how do you do this with security and compliance of the Gen3 Data Commons. So that's my perspective. I'm going to just speak at a high level based on my experience, again, not as an expert in security and compliance, but as someone who has to work with experts in security and compliance. I'm just trying to get these. All right, this is not going to work. I was trying to get a perspective of the screen that I could see the slides. So that's what we're going to do. We're going to look at 10 questions you can ask. So the first one, and this sounds like an obvious one, and this is obvious if you're in an organization, and if there's some and the organization is responsible for the whole project from soup to nuts. They're responsible for running the project. They're responsible for managing the users. They're responsible for approving the security. And then all you have to do is within your organization, you just have to figure out how your organization approves security and compliance. most research projects, or I should say, many research projects are not that simple. There may be a consortium that's doing the that's responsible, and the consortium may span multiple organizations. It may be a formal consortium, but it may also be an informal consortium that's not a legal entity, but just is a project from multiple organizations. There could be funders that are involved. There could be organizations providing the data. And for whatever reason, in practice, oftentimes it's not obvious without a little bit of work to figure out who's responsible for signing off on the security and compliance. And your first job is to figure out if there's some choice. And if there is choice, in the US, we have something called Murphy's Law that says whenever there's a choice, the worst possible choice comes up. So whenever there's a choice of which organization or which part of the organization is in charge, you want to think through it and structure your question knowing which way you may be able to steer it. So if there's an organization that is comfortable working with researchers, has done this for a while and has a way to approve these systems, then you want to use that. If there's an organization that may have very good security and compliance, but does it in the hospital context in which data typically doesn't leave the hospital except in very precise legal agreements, a research group building a commons may prefer to work with someone else. And so to review, if there is a choice, you want to figure out what the options are and what's best for the project. And if there isn't a choice, you want to understand this from the very beginning. And so, for example, in a commercial, if this is pure commercial and or corporate, then there's a corporate security office or chief information security officer. If it's at a university, there's oftentimes a research officer in charge of the security and compliance, or sometimes that sits under the security and compliance for the organizations. Security and compliance officer. But once you find that person, you want to figure out what the framework is. And so once when you're done with your security and compliance plan, there's a lot of paper. And if you produced all that paper for the wrong framework, then you wasted a lot of time and effort. So you want to understand initially, as soon as you understand who's in charge, what security and compliance framework they're using. There are often options, and you want to identify that so that you can structure your effort around that particular framework. I'm going to try one more time to just see my screen. Michael, are they seeing just the slides or the whole screen?
I see, now I see one slide.
Okay. So oftentimes in security, we have, oftentimes in security, there are multiple organizations involved. And to be in a very simple example, building a commons, you may be setting up the commons, and maybe, for example, there's an operations center in your organization, in your unit, or in some other unit that sets up the commons. Typically, there's some user services that work with the users. I have these boxes for the different units, and then organizations are in dotted lines. But if you think about it, you may have a commercial cloud provider. That's a separate organization. There may be a data provider, another university, that's in a different organization. And then users are typically in a different organization. And in a shared responsibility model between any of the organizations, here with the dotted lines, there are legal agreements. So before the users can use the data or touch the system, there's a legal agreement. Before data comes in, there's a legal agreement. Before you use a particular cloud service provider, there's a legal agreement. And not only do we have legal agreements, but with the shared responsibility model with security and compliance, each of these different units within each of the different organizations have specific security things they do. For example, Gen3 doesn't come with a firewall, but the operations center has to set up a firewall. There should be Gen3 has different ways of providing access to the data through workspaces, through APIs, through downloads and other ways. And that's a transfer of responsibility from one organization in the middle to the user's organization. So you should have a diagram like this, which is the shared responsibility model, because this will drive a lot of what you do. And then a basic question you should ask is, how well do you understand the difference between security compliance and operational security? Operational security are all the people in your organization looking at screens for threats, investigating threats, manning the different systems that manage security and compliance data and operating this. And in addition to the security and compliance document plan, which is a lot of paper, you really have to have people you trust doing the operational security. And how you split those responsibilities, sometimes said to be between government risk and compliance and operational security, or SecOps and DevSecOps, is one of the more important decisions you're making. What you outsource, what you don't, is one of the more important decisions you're making. Good security managers, good CISOs, Chief Information Security Officers, know how to work with you to mitigate risk. The simplest thing a CISO can do is to say no. If they say no, they reduce risk. But if they say no enough, the system becomes unusable. And so you need someone who can work with you on the security and compliance plan, but has enough experience that they know how to reduce risk, so they can not say no, but they can understand why other CISOs would say no, and they can get to a yes by putting in compensating controls, additional policies, additional processes to take a no to a yes. We're going to hear later from Plummet Martinov, and he's an expert in this. We're going to hear later from Clint Melsom. He's an expert of how to go from how to understand risk and reduce risk in very concrete ways by putting compensating policies, procedures, and controls in place. This is, for smaller organizations, you have fewer people and they have many hats. As the organizations get bigger, you're going to want to make sure you're organized so that all the things you need to do, from writing code with security built in, from checking code, from running checks on static checks on code and dynamic checks on code, and how you do your SecDevOps and SecOps, and how you separate out the governance risk and compliance, you may need to make sure that that fits into your organization in a good way. This, is one of the things you do before you even build the system, but, can you reframe the problem in order to reduce risk? Can you de-identify the data so it's less risky? Can you shift responsibility from your organization to other people's organizations? How do you structure the system? How do you structure the research enabled by the system? And how do you structure operations So by the very nature, risk is reduced. Clint just led CETAS through a spectacular tabletop exercise. Question to ask is, not do you back up data, but how often do you practice recovering data? How real are your tabletop exercises and how surprising they are? How often do you actually look for a threat that might not be apparent? And then, do you have people that you can compare notes with? So one of the things I hope you get from the Gen3 forum is a community that you can ask these very simple practical questions. So that's my talk, and I think we're delaying questions till later. Is that right, Michael?
Yes.
Okay.
You are right on time, Bob. So thanks.
I know they said I could have a nice relaxing drink of water if I was on time. So thank you.
All right, thanks, Bob. All right, our next speaker is Clint Melson, who's going to talk about security and compliance practices at the Center for Translational Data Science. So I'll turn it over to you, Clint.
Thanks. Hello, everybody. So I figured we would go over a few keys to deploying a secure Gen 3, and then maybe talk about some of our own practices here at the center. If you want to go to the next slide. So as you're deploying a Gen 3, cloud automation or Helm is only going to get you so far. We try to add security where we can, but a lot of it comes down to how you build the environment and your requirements. As Bob kind of mentioned, you have to know what framework you're going to build against. And that helps you get started. You then have to know and think past your framework and compliance. I typically start with a threat model. So get in the mind of that attacker, that malicious actor, who theoretically is going to come after your Gen 3 environment. And start thinking about, how do I prevent that? How do I securely design the environment to ensure that that can't happen? Right? How am I going to prevent the elevation of privileges? How am I going to, bring that load balancer and that WAF and boundary controls to make sure that spoofing and tampering and denial of service aren't going to happen? And so as you build that framework, as you start to build that threat model, even before you necessarily deploy Gen 3, you'll be able to really understand your boundary and the environment that you're going into. And that really starts helping not only in compliance, but in actual security operations. You can deploy Helm, our Gen 3 Helm or whatever, in a lot of different ways and in a lot of different clouds. And so really understanding that is definitely something to take into consideration. And then, of course, periodically retesting that risk model. And I think that helps a lot as you start to talk about compliance versus security. How do I reduce my risk so that we can say yes more? It starts with usually a threat model or understanding your environment a lot more. If you want to go to the next slide. So really, when you take that threat model and you really understand where you are in the environment, what your threat actors are, you can start to build controls to minimize that risk, right? So we talked about boundary controls. Gen 3 doesn't really come with a firewall necessarily, and we support whatever you want to bring. WAFs, right? Web application firewalls. How are you going to protect against bot attacks and all of those kind of things? We have a VPN, right, in our general design to give you access to the administrative VMs. Is that the environment that you want to continue, or is there some other design that you would like there, right? Cloud automation gives you the basics. But as you build that boundary, right, and you start to think about those controls, you're able to make smart decisions on how you're going to take care of your risk and minimize risk. When you get to the cloud, right, we're talking cloud security, posture management. It's the same principle, right? You've decided on a framework pretty early on, hopefully, whether that be NIST or CIS or any of them, somewhat dependent on what data you're hosting, of course. But you want to make risk-based decisions, right? Often when you deploy a CSPM, you're going to have, I don't know, thousands of vulnerabilities that it's going to complain to you about. And knowing your threat vectors and knowing your threat model, you're going to be able to better make decisions around what to prioritize. Yes, this security group isn't the most secure, but all traffic goes through a WAF and goes through a front-end proxy. So there's not a lot of actual risk here. We still have to fix all of those problems, but you start understanding what to do. That goes for encryption as well. This is often dictated by your compliance framework. If you're inside of NIST or FedRAMP or FISMA or any of those frameworks, right, it's going to be FIPS 140-2 or soon 140-3. So how do you make sure you're selecting the right applications, the right softwares, the right cloud configurations? Are you making sure your S3 buckets are encrypted at the right level, as well as RDS and all of the other services, right? Those are big decisions that you need to know very early on and check frequently. Encryption, I would say, is probably one of the harder ones to maintain over a long period of time, right? Terraform and other tools like that make it much easier, right? Because you're not making human mistakes, but ensuring that you have the correct encryption from the get-go is going to really be helpful. Gen3, of course, every month or thereabouts, we release a new version of Gen3, and in those, we're consistently adding new patches, we're fixing vulnerabilities, SAST, DAST, and all of those controls. We're always making updates as we go, and so making sure that you keep Gen3 on the latest version is going to minimize your risk as well and make sure that you're patching against vulnerabilities. Can we go to the next slide? I think one of the cooler things that we've been doing, especially here at the center, is enabling behavioral analytics. And this has been especially key in the cloud, being able to baseline using a bunch of tools, but baselining all of the connections, what traffic is going where, how data is being read, user patterns, right? Are we seeing large jumps in users? Are we seeing people logging in after hours or in different time zones or different locations? Do we see entire new features being developed in dev, and we'll start to get alerts, right, of changes to behavioral patterns. And as you do, it really starts to make you understand what's going on inside of your cloud environment and be able to filter out a lot of false positives or noise. If you're just using a DLP solution, right, you will probably get alerts every day because people are using the data inside of Gen3. But when you pair that with behavioral analytics, with traffic flows, net flow, VPC flow logs, you actually start getting kind of a normal baseline of what actually is going on in your cloud. And then if behavioral analytics tags something, you know for pretty certain that something is different, something is new, or we've moved outside of our normal pattern. And then you start looking for what was that? Was it expected? Did we have a change? Was there a change advisory board ticket? any of those things. But I think behavioral analytics has been one of the more interesting places we've invested at the center itself lately. It gives us a lot more confidence in what's going on in our cloud environment and in Gen3. And yeah, and you can use a lot of different sources, right? Flow logs, login data, IDPs, web traffic, data protection. The key is to put all of those data points together to really understand the baseline of Gen3 and your cloud. Then some key takeaways, of course, you should always be rotating and redeploying your containers frequently. Even if there's not a new version, rotating the containers is just good practices. Making sure that they're not running in privileged mode, make sure they're in read-only, that they can't hopefully harm you. Test your security. Tools like Infection Monkey, it's an open source tool from Akamai, helps you validate your security. You can actually do some pretty cool things with it, including sample ransomware, right? It will tell you how ransomware would spread in your environment based on how you've configured your cloud environment. It can even be deployed as a container. So the tabletop we did that Bob had mentioned, right? To get a lot of that data ahead of time, we ran Infection Monkey and actually took a look at all of the attack vectors to come up with a tabletop that was pretty realistic. But really, it's trusting and verifying that you've built a secure environment. On occasion, we also will launch a container that purposefully connects somewhere that we haven't seen before, right? We're trying to make sure our tools can actually achieve what they're designed to do. And of course, running tabletops. You really want to make sure they're realistic. A lot of us will go to tabletops or functional exercises because the auditors tell us we have to do them. But going past that and actually doing them internally, talking about what ifs. What if we get DDoSed? What is the plan? If we are attacked in this way, what are the tools going to tell us? What are the tools going to look like? If the system goes down and our platform team just sees over and over again that the malware tools are isolating an environment, and they don't know that that's what they're supposed to do, right? Will they just disable the malware detections, or will they understand that that's actually malware and they're being protected? So knowing what those tools do in those kind of scenarios across not just the security team, but operations and platform and engineering helps a lot. And running those tabletops can be fun. What ifs can be kind of a rabbit hole, but you get to have fun with them. We go to the next slide. So as I said, switching to security here at the center specifically, just for a few seconds. Like I said, we have worked a lot on behavioral analytics, really understanding what's going on and being able to find new features and new ways data is being used has been extremely helpful. We also have spent some time doing SOAR, so Security Orchestration, Automation, and Response. It's kind of a workflow engine, but piping the behavioral analytics into the SOAR further enhances that, right? It can build workflows. So if Michael is working remotely in a weird country and we weren't necessarily aware of that, the SOAR is going to go ask him over Slack or email, let's say, why are you in a different country and what are you up to? Or, in a nice way, but, it'll start asking those questions for you. We're focusing a lot more on open source and API first tooling. We want to be able to do more with API-driven security. We focused a lot last year on SecDevOps or DevSecOps, empowering people, training our developers, pushing out the OWASP models and pushing tooling into our CI and CD pipelines to make sure we catch security and vulnerabilities early. And then, of course, we continue with FedRAMP and FISMA, FedRAMP moderate and LISAS and FISMA moderate, and always balancing the compliance versus operational security. It's a balancing act, but bridging that gap with open source tools, with API first, and things like the SOAR and behavioral analytics helps make more informed decisions. And so all of those combined, I think, will allow you to have quite a secure Gen 3 as you deploy. And I hope those are items you've thought about as you do. Thanks.
Great. Thank you, Clint. Thanks for the words of wisdom and thoughts there. So next up, we're going to turn over to Plamen Martinov, and we're going to switch gears a little bit and talk about security practices for Gen 3 and applications. I'll take it away, Plamen.
Can you guys hear me?
Yes.
All right. Well, thank you guys for having me. I really appreciate it. Today, we're going to discuss a little bit about some strategic practices around Gen 3 and some of the work that we've been doing at the Open Commons Consortium for making sure the applications are secure. If you can go to the next slide, thank you. The Open Commons Consortium is a 501c3 non-for-profit organization, which is a division of the Center for Computational Science Research. What OCC does is operates cloud computing platforms, which are applications that integrate with Gen 3, as well as we operate data commons and data ecosystems to advance scientific research, medical and healthcare, and environmental research for societal impact. So OCC has been around for many years and has worked closely with the University of Chicago Center for Translational Data Science. And for example, some of the projects that we worked on is and continue working on is the ones for the Veterans Administration, Oncology Data Commons. We have other projects as well with the VA, but these are some of the highlights. Blood Pack Profiling Atlas in Cancer, which is called the Blood Pack Data Commons. And with the pandemic striking, we've all worked together on the Pandemic Response Commons, have the Chicagoland Regional Data Commons, and have also worked with organizations that have developed their own regional data commons as well. Next slide, please. In addition to the data commons work that we do with the University of Chicago, the Open Commons Consortium has created applications or cloud systems that we call them that integrate and advance some of the usability of Gen 3 platform. One of the key platforms that we've developed is credit card payments for using computing on Gen 3, where you could pay for use through a credit card or different means, which helps ultimately if a researcher doesn't have their grant has run out, or they just want to use the platform because it has useful data, they can ultimately use a different payment method. We have a governance platform, which helps onboard users into Gen 3. Something that was mentioned earlier by Bob was making sure there's the right legal agreements in place. So we've integrated things like DocuSign, where the documents can be signed, security training, and other components to making sure that the user has completed all the administrative functions before they can use the data or the data commons. As well as we have a function of providing stakeholders with information about how users use the system and how each user ultimately spends the competing resources, and we call that cost summary, which are reports that are provided to help the organizations understand how the utilization of system happens. Next slide, please. So getting into security from our point of view, I've had the privilege and opportunity to do this from multiple different angles. I used to work at the University of Chicago and help develop some of the security program at the Center for Translation and Data Science and the overall security program for the university. I've identified a few things here, and this is not an extensive list, but things that I think are very important. And it's a theme that I see that both Bob and Clint are mentioning here. And the first thing when working on developing a data commons or even an application for the data commons, you need to identify the legal entity, or from a standard perspective is called authorizing official, that ultimately can define the requirements, and ultimately you have a connection with this person to making sure that what you're working on and the way you're working on it meets the security and compliance requirements. This line of communication is very important because early on you can define all the requirements needed. Doesn't mean that you have to meet all of them at once, but as long as you have that open line of communication with this person or this entity, you can create a consistent process to making sure the expectations are met. So once you define these expectations, the second concept is internally to the organization, and you don't have to have a security team to do it. This is something that could be done by a security champion or somebody that ultimately can follow some of the processes, is identify a security standard that needs to be followed. If it's the AO that defines it, then you have a clear path. If there's not, you could identify so many different standards depending on the country or the stakeholder you're working with, and perform an alignment check or just an assessment to identify what's missing. You might have some security policies, you might not. Some universities, for example, and institutions have a central security office, some don't. So these are some of the items that we need to be identified early on to see where there are potential gaps, so that it will be very clear on what needs to be done. Like, for example, what security policies need to be created, and then how the security plan that you guys will create around the system are going to meet those requirements. This is not something where I have to be at 100% when you do this. This is an alignment and assessment to say, here's how much I meet today, and here's what I'm going to do to meet it over time. Which helps with the next point here, which is plan out resources and then identify technical expertise and skills that are needed. Defining roles and responsibilities. If you have a small security team or no security team, there are certain things that could be done with the people that you have. You just have to make sure that you allocate the right time for them to do it. For example, a developer could utilize 5% of their time to do certain security functions if they have to wear multiple hats, if you don't have a centralized security team. There's ways to do this. Ideally, of course, having more people, it's always the case, would be good, but usually it doesn't always work out that way. But there should be ultimately no excuse for not taking care of kind of the low-hanging fruit, at least at a minimum. But having those clearly defined and then coming up with a roadmap, which then helps you create a budget of how you can achieve greater capabilities over time, is a really key factor. So if I have to go down to the many things that security people have to do, to start with good security foundation, the first thing that I would say that you have to establish is a risk management, which is a process of identifying vulnerabilities versus threats. You don't have to create this, and reinvent the wheel. There's many different frameworks or processes that you can use. And this does not need to be technical by any means. This can include, hey, I'm missing this policy, or I'm missing this standard operating procedure, or things where there's gaps. And then ultimately, that could be a tool and a process to use to continuously manage, the maturity level of a security program to achieve some of the goals in reducing risk. As mentioned, everything is risky. And I think Bob had the best, graphic of how do you come from a no to a yes, right? Because in one concept is that the more secure bank is the one that doesn't have their doors open. But if you ultimately provide enough capabilities to reduce the risk, then a bank could be in business. And ultimately, a data commons needs to be in business in order to be able to fulfill some of the objectives and goals in research. I think the second thing that's very important is to develop what is called a Kanban, or that's a short version of saying continuous monitoring, which is a process to review and prioritize both technical and process shortcomings. You need to have a technical representation and also an executive representation or decision makers to review the things, and then everybody can agree on things that we're going to tackle next. And this is another way ultimately to continue supporting the security functions that need to be done. Everybody agrees that nothing could be done at once, but there are also ways to communicate this information, and continuous monitoring could be done, with stakeholders, and continuous monitoring could be done with organizational leaders, tech leads, as well as managers, so that everybody understands, where the shortcomings are, and then everybody can support the work that's necessary to reduce risk. And I know that Clint mentioned this multiple times, and I think it's very important too. Establish I call it continuous training, but which includes like tabletops for incident management, but it goes above and beyond that too, where having a smaller organization, right? Everybody has to pitch into security, but you cannot expect everybody to know security because they're in IT. So these exercises, and sometimes seen controversial to different IT people because they don't have the experience, it's a way of practice. So if you could explain it to individuals that this is not rating anybody, this is not reviewing somebody's experience, this is just identifying ways we can improve. It's a good way to make this a positive experience versus something that people dread. Next slide, please.
Sorry, excuse me, Plumman, just a quick time check, that we're coming up on 20 minutes soon. So I know you have a few more slides left, but just wanted to give you that.
All right, I'm going to go through this, and the rest people can read. I think this is very important component, interoperability models. So I'm going to try to cover it as fast as possible. So thank you for that. So in the FedRAMP component, there's two different models. So there's actually a third model, which I can discuss later. But ultimately, either an organization, when interoperability, dealing with different organizations and different Gen3 systems, could be outside the FedRAMP scope, or they could be inside the scope. And these two diagrams, one on the left depicts of how, for example, the green box is outside the scope, which is one of the things that we do with the payment portal. And then on the right side, where inside the orange box, inside the blue box, inside the scope. I'm going to quickly go through it. Go to the next slide, which is going to zoom into it. And I'm going to just give a quick synopsis on this. So to be outside the scope, when you interoperate between different systems, you have to avoid sending sensitive information. And sensitive information could be from PII, PHI, or other organizationally defined sensitive information. If you're outside those data boundaries, when you interoperate with APIs through a secure means, you could be outside the support boundary. That's what it means. You can create applications and utilize metadata to translate it in order to do it. And this is how OCC has done it with the payment portal, where we've generated a billing ID, where all information is exchanged with just a billing ID without identifying an individual user of the system. And then next slide. If you want to exchange sensitive information, like including just even email addresses and other types of PII, then you have to operate within the authoritative system boundary. In this case here, depicted how CTDS and how we do our customer reporting, because we're exchanging sensitive information like email addresses, which we consider sensitive. We then operate within their boundary, but we're still able to produce the same results. And these two different models are just two examples. An alternative model that I have not depicted on here is if the two systems have the same authority to operate. In the United States, it's FedRAMP, where the two systems are on equal authority to operate levels, where then you don't need to have this. But if they're not, these are just two different models where you still could exchange information that's sensitive. It's just where you operate on them. And I'm going to take one more minute. If you can go to the next slide. Okay, I'm not going to go over all this, but the one thing that I want to point out here on this is that the really best practices is that you routinely set time aside for staff to perform security hygiene practices. And you need to empower your staff to take action. So for example, at OCC, what we do is that if somebody somehow is set up with a login to one of our systems and they don't have MFA enabled, any staff member, irrelevant of their position, can remove them immediately. This is just one example. But ultimately, what I was trying to preface here is that before connecting systems or running a data commons, make sure that you identify your requirements, make sure you identify your legal entities, make sure you identify your authorizing official, so that you can have a successful system that meets organizational requirements. And then ultimately, over time, you work to reduce risk. The rest you guys can read later because I'm running out of time.
Okay. Thanks, Pawan. Thanks for all the info. And as people said, or as you said, people, yeah, we'll make these slides and the video available so you can review later. So okay, with that, I'd like to turn it over to Colin Griffin, who will be talking about securing cloud native and Kubernetes. So take it away, Colin.
Cool, and I appreciate it, and I apologize. I'm overseas, so at the moment, so if my video gets a little spotty or my audio, someone wave at me, please, so I know how to pause. Anyway, hey guys, I appreciate everyone taking the time. My name is Colin Griffin. I'm with Crumware, and we are cloud native application developers and platform developers. We specialize in Kubernetes and cloud native applications across all cloud providers. But you can jump to the next slide. We got involved with the Gen3 project via Wake Health we started our involvement with Wake Health to help support their Gen3 implementation and primarily their Kubernetes implementation to host the Gen3 environment. And I recognize that many of the folks in the Gen3 community may not be intimately familiar with Kubernetes as a practice. And so I wanted to take time today to cover some general practices with Kubernetes, as well as some things to look out for. So next slide. So Kubernetes is essentially a project that lets us create our own cloud environment. I'm way oversimplifying when I say that, but with great power does come great responsibility. We'll typically operate cloud environments across multiple cloud providers, but to our developers and to our users, it looks like a single access plane for our applications. It gives us all kinds of great things like immutability and resiliency and great ways to combat threats using those tools. But these are some key things to watch out for with your Kubernetes implementation, and some things that you can reflect back to your infrastructure teams to watch out for as you grow your Kubernetes maturity. So Kubernetes enables microservices and containers as concepts. It's a really, really strong tool, and it gives us a tremendous amount of resiliency and configurability with those tools. But it also means that we're introducing many, many, many different individual machines at the same time. Traditional security protects at the boundary and has to deal with less machines in quantity. And Kubernetes is a bit of a new playing field for vulnerabilities and security teams with the fact that we actually are increasing our attack surface in many situations. So it's highly configurable, but it also can mean highly unsecure. So system components of Kubernetes also come inherently insecure out of the box. It's something that needs to be locked down, and that is out of preference. It's something that the implementer of the system should be making decisions on. And so that's something to watch out for as well and not to be skipped. And I'll introduce some tools for that here in a moment. Securing the network boundary is not enough. Each pod itself, so that's a unit of compute in Kubernetes. It itself is a network boundary. It has some awareness of the systems around it, but breaching a particular pod could lead to additional risks. So traditional security tools, again, will protect people from getting inside of the network in most cases. But if one of our containers, if one of our systems is already compromised, then it makes it easier for folks to make man-in-the-middle attacks or to sniff network traffic coming from container to container and between systems, which is something we absolutely don't want to happen when exposing traffic, especially in the healthcare space. Also, many different types of teams in an organization will probably have access to a Kubernetes environment, or to the cloud environment in general, and a lack of maturity in that environment can expose errors in configuration and can create security holes. And I really, really liked that call out about multi-factor authentication. We need to introduce additional tools. So next slide, please. This is just a quick diagram just to show some of the complexity of the components. On the left is a general architectural diagram of the Kubernetes system components. Those are the things that communicate with each other and do all of the nice things that hopefully allow us to sleep at night as opposed to getting an alarm on pager duty if the system goes down. On the right-hand side is a general architecture diagram that we've made in the past for our auditing for the internal components of the Gen3 environment. And as you can see, there's a lot of network traffic and a lot of different complexity going on there. Next slide, please. So some different tools that you can use to try to secure your environments. And it takes time to get maturity in these, but these are good starting points, and we can't possibly go entirely in depth into these tools today. There's an OWASP cheat sheet that runs through a number of best practices for Kubernetes. That should be a starting checkpoint, at least, when creating your Kubernetes environment for the first time. We need to introduce additional types of security tools, especially in our CI/CD chain. We need to do container scanning pre-deployment as well as post-deployment and runtime to make sure that these open source components that we're deploying have not introduced unintended vulnerabilities. Supply chain threats are a huge concern right now in the industry, and tools are evolving every day. But we at least need to start scanning so that when we enhance our scanning tools, we already have those automations in place. Also, we need to introduce additional controls for network monitoring and protection. Again, as traffic passes often unencrypted inside Kubernetes, if we introduce tools that encrypt our traffic for us and enforce those policies and workflows, then we don't open ourselves to we're still open to it, but we help limit our risk to actors or creators of open source projects to unintentionally introduce vulnerabilities into our projects. Also, we need to introduce policy management and role-based authentications and controls. It's important if we're creating our cloud environment that we often isolate ourselves from the tools that are provided by folks like Amazon and Google, and we need to implement and create those ourselves or use a tool in many cases. Google and Amazon do have their own sets of controls around that, but it still needs to be a consideration as we do implementation. There are several open source projects and tools that we use for Wake Forest to help enhance our abilities and our workflows as we help manage that environment. One of those is Rancher. It's a Kubernetes orchestrator. It helps do a lot of the heavy lifting for some of the policy creation and management, especially the single sign-on and role-based authentication and controls. So we can limit what users are able to do when they're able to access the system. So DevSecOps teams and app dev teams and IT ops teams all have different roles and capabilities within that platform. We also use a tool called NewVector. And NewVector is a cloud-native security solution. It's very unique in its capabilities. It actually does runtime monitoring of network traffic, securing network traffic. It has built-in heuristics and does container scanning as well. And we'll talk about that in a moment. And we use additional cloud provider tools. And an example in this case, since we're on GCP for this environment, is limiting boundary access via like the gcloud CLI to authenticate with Kubernetes. Also, I wanted to include, it's not all about layering on additional tools. There are built-in security controls and tools in RevProxy, Fence, and Arborist, and some of the other systems. So you can have trust in the Gen3 project as it is today. But we do need to make sure that we monitor and have a layer of mistrust around that to provide additional security. Also, we're evaluating Istio. Istio is a really powerful service mesh and load balancer, and it helps us have additional tools around our network traffic. Next slide, please. Time check. Yep. So we wanted to talk a little bit about NewVector, and it's important to us. NewVector is a free open source tool. It's by SUSE, which is one of the longest running open source companies in the world. There are some unique capabilities that we get, including some abilities around shifting left with NewVector. We get our image and registry scanning, so we can scan at runtime, we can create integration testing environments, and we can scan in our sandboxes and make sure that we promote security rules from dev to stage to QA and to production and have an escalation pathway. So we don't break our applications, but we also maintain as much security as we can. There's also continuous monitoring and behavioral learning in place. So NewVector does some detection of anomalies and tries to create rules on the fly that we can then blacklist, whitelist, and validate and do things there. Also, one thing that's really important to us as developers is introduction of the capability of security as code. What our IT ops and DevSecOps teams are able to do is monitor the NewVector network traffic and use NewVector just like any traditional cloud security tool and create these create policies, WAF rules, do data loss prevention, deep packet inspection, monitor for and deep packet inspection is monitoring actual network content for things like transfer of social security records and or log4j packets and things like that. But we can actually create an escalation pathway where those policies get exported and can be delivered back to our app dev teams for inclusion in our CI/CD pipelines. So the next time we produce a release, or maybe our security rule promotion is part of our release, those rules will automatically roll out through the different environments and have different configurations. All right, next slide, please. NewVector also ships with a dashboard that makes it easier for folks that might not have in-depth understanding of Kubernetes to apply their security expertise in a Kubernetes way. It also comes with complete compliance breakdowns for HIPAA, PCI compliance, and other frameworks that will scan against known CVEs in the open source to help us detect and mitigate against those concerns. It also contains a bunch of information about how to rectify those. So we can scan our container images, scan our physical nodes, monitor our network traffic. It's really powerful there. And for policies, sorry, I'm having trouble seeing because I have a light on me because it's dark in here. let's see. Yes, we can create new policies and predefine policies, as well as modify those policies in code on the fly. But that helps us also share our policies and code with other folks so that we can work together as a community to try to lock down our security. Next slide, please. Let's see. So again, in our dashboard, we're able to see our detected vulnerabilities and manage vulnerability profiles and create custom rules. We get our compliance service summaries and also exports, so we can prove our compliance levels against those CVEs and those known policies, including the MITRE ATT&CK framework and some of the other tools. And we also get what you'd expect. We'd get our notifications for security event tracking, also non-critical event tracking. So you don't always necessarily want to block traffic. You may want to just alert, so you can choose to add that rule later or determine what to do with that. And we also have risk reporting down to the container level. A lot of these cloud native tools don't get down into the container or the inner pod level. They just protect the boundary. So that's really useful for us. Next slide, please. See, I probably don't have time to demo today, but I'm happy to share our live new vector environment at another time with folks. And I wanted to touch again, just in general, on that app, the security as code. Since we can export our policies as Kubernetes resource definitions, what that actually enables us to do from a Kubernetes standpoint is we can include those security definitions in our Helm charts, and we can make them entirely optional. So if you don't have new vector installed, those policies will not affect you and they will not get deployed into your environment. And that makes it really useful if you choose to opt into using a tool like that at another time. And in the same vein, so we say Gen3 Helm here, but I didn't want to be presumptuous, but we're going to be donating our base new vector security profiles back to the project by the end of September. We're running through testing and verification of that right now, and we hope to take that through tabletops as well. It was a great call out. It's really important to do those and actually test your security rules in live action. But we hope to do that by September 27th. We don't beat that deadline. But ideally, we want to find a way to share security within the community and enable other teams to be able to secure their environments as well. And I think that's the end of my slide. So I thank you guys for letting me talk today.
All right. Thanks so much, Colin. And then before we turn over to questions, just a quick thank you to all the speakers, as well as the additional Gen3 Forum Steering Committee. So with that, really just gonna open it up for questions. Either feel free to type in the chat or raise your hand and we can select you to unmute. Right. I'll start off with a question if I don't see anything. Maybe this is for Bob, but it could be for any of the speakers. So many Gen3 Data Commons have to deal with biomedical data, but are there any considerations, that an operator should keep in mind if they have, vastly different types of data just right off the bat, where HIPAA isn't a concern, it's just engineering data or atmospheric data. I'm just curious if there's some levels of security that different data types would require. I guess that's a broader question.
I'll let everyone give their perspective. At a high level, security is about, protecting, confidential in the keeping is about confidentiality, data integrity, data availability. All those dimensions are independent of the data type. What you have with biomedical data is you typically have different tiers of data, some open access, some registered, some controlled access, some perhaps very sensitive and even more controlled access. You can have that with any types of data. Biomedical data has different levels, typically, as I described. In addition, biomedical data includes healthcare data that has regulatory consequences of breaching privacy, and there's a whole set of regulations around it. So from a securities perspective, and I'd like to hear the perspective of the other speakers, I would say no. From a regulation and compliance, there are a lot of differences, and in healthcare data, there are a lot of differences. There are some differences from state to state. So, you can look at the question in two ways. You protect systems because there could be ransomware, even if it's not biomedical, there could be breaches, etc. You protect your users. That's independent, but there are these other types of issues around regulatory and perhaps other types of attacks that are different with biomedical data. Why don't we hear briefly from Clint, then Plowman, then Stephen?
Yeah, it's really about protecting the system as a whole. And I typically go to whatever is the strongest of the security practices. So like NIST will often encompass other controls, or you may just look for the matrix of where the strongest control that you're going to have will be.
Plowman, do you have any thoughts?
Yeah, no, yeah. I mean, I agree with this. I mean, there's certain biomedical data, genomic data too, that under United States laws, it's very ambiguous, and we've dealt with this before, where irrelevant of what it is, doesn't matter how many SNPs you have, it's all considered PHI. But ultimately, right, establishing the right baseline of security, right, having the right access controls in place, and then having fundamental security practices would help reduce the risk. But it's a continuous process, right? Like, you can't just install a piece of technology and say, well, we checked the box. We have to ultimately continuously progress and mature and look at things and look at threats and prioritize to continuously reduce the risk. And that's the whole job of security, and the data that organizations that have biomedical data or other information have to deal with.
I just want to thank Colin for his great talk, and I meant for Colin to respond after Plowman. So Colin, that was a great talk. What are your thoughts?
Yeah, I absolutely appreciate it, Bob. I echo the same thing. If anything, to take a different perspective on it as well, the baseline is incredibly important, but also is standardization across teams. If we start to, within a certain level of compromise, if we start to deviate and change the way that our security teams operate for each individual application or project that we run internally, then it's just going to create confusion. And things will slip through the cracks. If we can standardize on that baseline, even if we overprotect a little bit, and we know we'll have to relax those rules in some places, then it'll generate efficiencies and help everyone operate better. And that's really important.
I want to call out what Colin just said. I mean, almost all security teams are too small for the job they need to do. And no matter how small your organization, if you try to run different systems in different ways, it just is a bigger burden. So what Colin said is incredibly important from a practical viewpoint. You want to, as much as possible, just use best practices, the same best practices in all your systems. Almost no team is large enough to do something else, and it's also more likely to make mistakes. So what he just said, it may sound simple, but from a practical viewpoint, it's incredibly important. Back to you, Michael.
Thanks, everybody. Yeah, those are good perspectives on the question. I don't see any other questions. Any questions from the room?
I have maybe a comment more than a question. Thank you very much to all the speakers. It's been a really useful. I think we're maybe slightly less mature than some of these, so this has been a really useful perspective for us. And I think the sort of the broader context of thinking about Kubernetes and cloud native sort of outside of just the core Gen3 has been really useful. So I'm sort of still digesting. I don't have a question at this point, but just really to say thank you very much. It's been brilliant.
And I've got a comment as well, Michael, if that's okay.
Yes, please, Colin.
So I just wanted to emphasize, like, we do a lot of work in open source projects, and the strength in these open source projects is really about the community and the strength of the community and sharing information amongst the community members. And we've seen a lot of really great stuff there in Gen3 in general. So we're really happy to be contributors, to be welcomed as contributors in the environment. It's easy for groups to be exclusive and to kind of hold things tight and be protective. But I'd encourage everybody. Security is not typically thought of as part of the process with open source. It's just something that an organization, or a group within an organization performs for somebody. But it's very important in open source. And if we can find ways to share risks that we find, threats that we find, as new vulnerabilities come out in the systems we're using to host these things, sharing those in the community is going to be incredibly important. And so I'd encourage everyone to consider security as they contribute back to the community here.
Thanks, Colin. Well, we're happy to have you as part of the community. It's very helpful. I did have one other question that has come up in a couple of the talks that might be people might have a little bit more to expand on. The topic of a small organization that's setting up a Gen3. I think a couple of people alluded to this. Are there any particular thoughts that any of the speakers have on how, as a small organization, you can tackle some of these important questions that were raised today?
I mean, we are a small organization managing quite a bit of data commons and developing applications. But I think the concept of everything is, I know this is, mundane, but it's people, process, technology, right? People and process are very important. And I want to emphasize on the fact that, everybody in an organization has responsibility, right, of security. Security is part of the fabric of an organization. And, identifying the requirements early on, just like, developing an application or implementing a technology, is very keen to making sure this works. And, security is, it's not a sprint, it's a marathon. And if you can communicate, as, Colin mentioned and Clint mentioned and Bob, the risks, right, appropriately, right, you can succeed over time. Like, nothing's going to happen overnight. So in a small organization, having everybody spend time on security is a very important concept.
Yeah, I think.
Oh, sorry, Clint, were you going to say something?
Yeah, I think understanding that risk, just understanding how Gen3 works at a high level or a more detailed level will help. Because as you understand it more, you can make those decisions. But also, pushing things left into your developers or everybody's hands. Security isn't just the security team's problem. It's everyone at your center or whatever. It's ultimately all of your. It's all ultimately about the culture of security is here, and it's everybody's responsibility, and everybody needs to pitch in. The people who develop your code or integrations are the ones who will know the most about that. And if you help make them security partners, it will vastly help make it a more secure environment and make it easier on the security team.
Colin or Bob, did you have more to add?
Nothing from me. Any comments from from any of the other people on the line about this question? It is a question that is asked quite a bit.
I think
Oh, go on, Colin.
I was going to say one last thing. Just I don't not to be to echo too much about the community, but again, if you're listening to this and you're not in the Slack channel, go get in there. Don't be scared of Kubernetes. We know it's complex, but it's getting easier and easier every day, and tools are maturing and making it easier for smaller teams to consume and deploy that way. And it's becoming commoditized. It's becoming the standard way to run cloud. So get in there, ask for help. Don't be scared of it. There's a great community there to support you.
Yeah, and I want to echo what Colin said in that, you know, it's the reason we're having these Gen3 community calls is we're committed to building a Gen3 community from organizations around the world. And anything we can do to foster that, you know, it's important. So reach out on Slack, reach out any way you want, but you know, we're committed to building the broader community. You know, we can't, if we don't do that, we can't take Gen3 to the next level. And we want an open source solution out there for all the uses that are so important, including the emerging uses in AI and machine learning. So please reach out. I think if there are no more questions, Michael, do you want to remind people when the next meeting is? I guess it's about 2 months from now. Do we have a date yet?
We do. It is it's November 1st. So November 1st at the same time is our next Gen3 community event. I think we have some ideas for topics. I don't know if we've fully decided on a topic. So if you have ideas, please send them my way or in the Slack channel. We'd love to hear them. We want to make sure that these events are, you know, cover useful topics for the community. That's what they're for. So keep letting us know how we're doing, or if there's some other topics you'd like us to cover. Okay, if there's no more questions,
I want to thank Clint, Plowman, and Colin one last time. It's always work to give a talk, so thank you. And we'll see you all in about 2 months. So have a good day or evening.
bye everyone.
Bye.
Thank you. Cheers.
Thank you.
All right,
Bye-bye.
thank you. Bye, guys.